Okay, we're setting up our statistics notebook. We're going to use this for the entire semester, so you'll need to make sure to hold on to it. Make sure you put your name on the front and label it statistics so you know which one. You have a whole handout that says on cutout. You'll need to cut this out and tape it down. This will be where we put things that we're working on as we need to do it. And then page 1 is going to be the table of contents. There's a sheet that looks like this. This is what we'll be doing each 6 weeks. So as you can see, in the first 6 weeks, we will be talking about the data statistics overview. That's going to be a lot of vocabulary, some samples, information that you'll need to work on. We're going to be looking at some experiments and even setting up a couple of example versions. We'll also be looking at describing distributions of data. This is basically talking about making charts. We'll be making some bar graphs, some pie charts, histograms, which are special types of bar graphs. We'll be looking at the mean median mode, the interquartile range, which is what IQR is, the standard deviation. These are measures of variability. There's several equations that we'll be working with and functions on our calculator, which we'll be doing. I'll make videos for each of those. During the second 6 weeks, we will be looking at modeling. This is where you're going to take your data and compare it to break it down into something called percentiles and z-scores that'll allow you to determine whether or not a hypothesis is making sense or not. In the third 6 weeks, we are going to be looking at how things correlate. Correlation is where you are seeing how things are related. If they're related in a positive way and a negative way, if there's absolutely no correlation whatsoever, if it makes any sense that there's any correlation, what's causing things to be correlated, that kind of thing. During the fourth 6 weeks, we are going to be looking at samples. This is where you're taking a smaller group of information, things like, say, a classroom's responses, and then applying it to a population, which is like the entire high school's opinions. So that is kind of the situation there. That involves a lot of equations, multi-step activities, but it's actually pretty similar. We'll actually be using pretty much the same formulas all year round. It's just applying it in different ways. During the fifth 6 weeks, we're going to be doing some probability activities, using dice and that kind of thing. This will be a lot of hands-on, but then again, it will also be some project-based ideas. And then finally, in the sixth 6 weeks, we will be looking at another form of inference, which gives us an idea of how things are working in proportions. Again, something to do with probability. Probability is a percentage of something. Proportion is also a form of percentages. So that is the intro to that. The beginning of our lesson, the very first thing we're going to look at is the definition of statistics. So what is the definition of statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. What is data? Data consists of information coming from observations, counts, measurements, or responses. So this is something you either see somebody doing and you count up how many times they did it, or the number of times that someone has responded to I like subject A over subject B, or it could be a response to an email or a Google form, that kind of thing. And we're going to use several different methods to collect data in order to actually build a data set. So list some of the places that you are exposed to statistics. Think about it. Where do you go? Where have you seen statistics spouted? i.e., the news. You might have seen it on the news where they're saying 90% of people are doing this or something like that. Magazine articles. When we'll be looking at several articles and pointing out the statistics and also the viability of that statistics. because a lot of statistics is very, very skewed to one point of view or another. Commercials, 9 out of 10 dentists prefer, blah, blah, blah. Sports statistics, how many runs bats. See, I'm not a sports person. Okay, so basically, how many home runs does that person get? How many strikeouts? That kind of thing. Yardage ran. If you're a sports person, you'll love that part because it's lots and lots of statistics. So now at the very bottom, I want you to write 5 different statistics that you have been exposed to this week. Some things that you might have seen, some sports statistic that you might have heard on the radio or read, some kind of statistics that a teacher might have spouted, something that you might have heard on the radio or on the television, anything you want. All 5, I just need 5 things. Put them as bullets, please. All right, page 2. So different types of data sets. There is a population. Populations are the collection of all outcomes, responses, measurements, or counts that are of interest. A population is literally you ask every single person in whatever group it is that you're measuring for their response. So as an example, a population might be the entire student body at Temple High School. And you might go to every single student and ask every single student, what is your favorite subject? And then record what their response was. But you have to get every single student in the high school. Okay, a sample is a subset or a part of the population. So instead of going to every single student in the high school, you go to, say, 5 classes, and you ask those 5 classes, the students in those 5 classes, what is your favorite subject? And if those 5 classes, and that you make their response, and then you infer from their response how the population would have responded. So let's say that out of those 5 classes, 70% of the students said their favorite class was math. Yay for math. But 30% said it was some other thing. So then you would infer that 70% of the Temple High School population loves math. Now we all know that's probably not true, but hey, a girl can dream. All right, so a parameter is a numeric description of the population characteristic. So a parameter in this case would be talking about the entire high school's responses, and it's the numeric value that came up with. So 70% of Temple High School students love football. That the parameter there is the 70% of Temple High School students love football. So football is what they're loving. 70% is the numeric value that says that that's how many loved it. Statistic is the name for the numeric description of the sample. So in this case, you would again be looking at those 5 classes, and 70% of the students in those classes loved football. So in that case, you're talking about the smaller group. You're not talking about the whole population yet as of right now. What we're just saying is that in that scenario, that sample said 70% loved football. So we call that a statistic. And when we're talking about the entire population, we call it a parameter. Now, something to remember, population parameter, they both start with P. Sample statistic, they both start with S. There will be a question on the test that will say, what is the numeric description of the sample characteristic? And you need to know its statistic. And you'll see both of these on there, but it's easy. Just match the letters. All right, so at the bottom, I want you to do the matching key terms. You can see it here to check, but I want you to go ahead and try it yourself. All right, that's all for today.